Hi, in homework number 1, there is a problem about explaining FEV as a function of age, of height, and of the interaction between age and height. And in this video I'm going to try to go through with you how you might try to understand a model like this. The first thing to do to try to understand, for example, how height might impact FEV is to make age fixed. So let's just fix age at 10 years of age and then examine how does FEV change when you change height. And so what I'm going to do is plug into this model age equals 10. So that means that we have beta naught plus beta 1 times 10. I plug 10 right there. We're going to hold age fixed at 10 for the moment. And then we have beta 2 times whatever the height measurement is. And then we have beta 3 times 10 times height, which means we have beta 3 times 10 times height here. One thing to notice is that beta naught plus beta 1 times 10 is just two numbers added together, and I'm just going to put them together as this intercept. And then I'm going to notice here that you can factor out the height variable out of these two terms and bring it outside right here. And that leaves what's inside is beta 2 and beta 3 times 10, or 10 times beta 3. From that, then notice from your output that beta 2 hat, I'm thinking about this slope right here, beta 2 hat is about 0.046 from the output in the problem. Beta 3 hat is 0.075. And so when you multiply 0.075 times 10, you get 0.075. And that means this is a positive number, this is a positive number, and when you add them both together, you get a positive number, and it means that as height goes up, you get an increase in FEV. And how much? Well, these two things added together, which looks like about 0.12. It looks like you get about a 0.12 liter increase in FEV for every unit of increase in height. And so that's how you can understand how height is changing and impacting FEV for a fixed level of age. You really can't just say there's one impact of height, because if you change age, what's going to happen is this number, like say you change it from age 10 to age 12, this multiple will be bigger, and that means this contribution will be bigger, and it'll mean the slope is bigger. So for an older person, it looks like what's going to happen is, so here's younger, an older person is going to have a steeper slope. And that's how height is going to have a bigger impact for an older person than a younger person. It's because age is impacting and multiplying this interaction coefficient, and that's why it's changing. To understand the age effect, you'll do exactly the same thing, except instead of holding age fixed, you'll fix a height, and then you'll work out the slope for age, and it'll involve beta 1 and it'll involve beta 3 times a height. And I hope that gives you an idea about how you're going to understand a model that has an interaction. As always, let me know if you have questions.